of tin. A fuel line must be large enough to provide enough fuel flow for maximum power. It's supported under the vehicle by nylon insulators and brackets. Reinforced synthetic rubber hoses allow for movement and vibration of components. The reinforcement is needed because the fuel line is subject to variations in pressure. Injected lines are made of cold-drawn, annealed seamless steel tubing. The bore of the pipe is kept to the smallest diameter possible, and all of the pipes are the same length. If pipes of different lengths were used, it would affect injection timing. This section examines fuel filters for diesel engines. The fuel filter removes abrasive particles and water that could damage the accurately sized and polished injection equipment. The most efficient filtering system uses the first filter to remove larger particles and subsequent filters to remove smaller particles. Water traps and sedimenters trap water and larger dirt particles. They can be separate units or combined with an impregnated paper element filter. Separate units pass the incoming fuel over an inverted funnel. At the edge of the funnel, the fuel changes direction very quickly. Water and dirt are heavier than fuel, so they are trapped away from the funnel edge. They fall under gravity and settle at the base of the sedimenter. The lower housing is usually clear for easy inspection, and it can include a drain plug, so sediment can be drained off daily. The most common type of filter material in diesel vehicles is resin-impregnated paper, pleated to offer a large surface area to the fuel. These filters are also considered the most efficient. In some of the filters that use this paper, fuel flows from outside to inside. In others, it flows from the base to the top. In others, from top to bottom. A fuel filter with the resin-impregnated paper element can be combined with a water sedimenter. When this combined unit is used, the method of fuel flow is determined by the manufacturer. One method has fuel pass through the paper element first to trap abrasive particles. Any water in the fuel is usually in the form of small droplets, which are forced through the paper element. Once through the filter, the small droplets combine into larger droplets and form a sediment layer in the base of the filter. The bowl may be transparent and it contains a drain plug. Other types pass fuel into the sedimenter first and force the larger particles out of suspension by a change in direction. The fuel is then forced through a filtering medium ready for use. The base usually has a drain plug for daily draining of the water from the filter. This type is usually contained in a disposable element. A water level switch can activate a light on the dash to warn the operator the sedimenter chamber may need draining. The switch has a float that is lighter than water but heavier than fuel. In the float is a magnet. As the float rises on the water level in the fuel, the magnet closes a reed switch, which turns on a warning light in the instrument cluster. The operator can then remove the drain plug to drain the water. This section examines fuel lift pumps for diesel engines. The lift pump transfers fuel from the tank to the fuel injection system. In modern vehicles, the tank is mounted below the engine, and the fuel has to be lifted up to the level of the engine. Three types of lift pump are common on light vehicle diesel engines: the diaphragm type pump, the plunger pump, and the vane pump. The diaphragm type pump can be mounted on the engine or on the injection pump. It is fitted with inlet and outlet valves. and an eccentric on a camshaft acts on a two-piece rocker arm connected to a diaphragm. Rotating the eccentric causes the rocker arm to pivot on its pin and pull the diaphragm down. This compresses the diaphragm return spring and increases the volume in the pumping chamber above the diaphragm. Atmospheric pressure at the fuel tank forces fuel along the fuel line to open the inlet valve. Fuel flows into the pumping chamber. The eccentric keeps rotating and the rocker arm is released. The spring exerts force on the diaphragm to pressurize the fuel in the chamber. This pressure closes the inlet valve and opens the outlet valve, letting fuel be delivered to the injection system. If the system doesn't need all of the fuel delivered, the pressure in the outlet fuel line rises to the same level as in the pumping chamber. That holds down the diaphragm and keeps the diaphragm return spring compressed. When this occurs, the split linkage in the rocker arm allows the lever to maintain contact with the eccentric without acting on the diaphragm pull rod. A second type of lift pump in light vehicle applications is the plunger pump. It's mounted on the inline injection pump and it's driven by a cam inside the inline injection pump housing. Internally, a spring-loaded cam follower converts the rotary motion of the camshaft into reciprocating motion. The reciprocating motion is transferred to a spring-loaded plunger fitted with close tolerance in a cylindrical bore. It has two spring-loaded check valves, an inlet valve and an outlet valve. As the engine drives the injection pump, the lobe of the camshaft pushes the cam follower into the plunger pump. The cam follower acts directly on the plunger, pushing it towards the end of the cylinder bore. Fuel is displaced from one side of the plunger through the outlet check valve to the other side of the plunger. When the cam follower retracts, spring force on the plunger moves the plunger out of the cylindrical bore. Fuel from the fuel tank enters behind the plunger through the inlet check valve. Fuel in front of the plunger is displaced out of the pump to the fuel injection system. If the quantity of fuel required is reduced, so is the movement of the plunger. A vane pump is used in distributor-type injection pumps. It is also known as a transfer pump. It is mounted on the input shaft in distributor-type injection and pumps fuel whenever the distributor pump is driven by the engine. It consists of a rotor mounted off-center in a pump housing. Slots are machined in the rotor to carry vanes. As the rotor rotates, the vanes can move into and out of the slots. The vanes seal on the edges of the rotor slots and the pump housing. As the pump rotor rotates, trapped fuel is carried around by the action of the rotor until the leading vane uncovers the outlet port. Since the rotor is offset, as it turns further, the volume between the vanes reduces and fuel is squeezed out of the pump. A pressure relief valve controls the pump's operating pressure. All diesel engines in light vehicle applications have a priming lever on the lift pump or a separate priming pump to allow for removing air from the fuel system. This is called bleeding or priming. Air can enter the system during filter replacement or when a fuel line is disconnected. Without a priming facility, the start motor would have to crank the engine over to bleed and prime the system. Excessive use of the starter motor for this purpose would damage it, and it would soon discharge the battery. This diaphragm lift pump has a lever that acts on the diaphragm rocker arm. Moving the priming lever moves the diaphragm down. Releasing the lever allows the diaphragm return spring to force the diaphragm up. The action of the diaphragm and valves during bleeding is the same for normal operation of the pump. Since distributor-type injection pumps use an internal vane pump, their fuel supply system incorporates a diaphragm-type priming pump, usually located on top of the fuel filter. This filter housing includes a diaphragm-type priming pump. The diaphragm is connected to an actuating button, and it's held in its uppermost position by a diaphragm spring. Reed valves connect the priming pump housing to the filter. Pressing down on the actuating button reduces the volume in the pumping chamber, which forces fuel into the filter element. Releasing the button lets the spring lift the diaphragm, which increases the volume in the pumping chamber. Air pressure in the fuel tank then forces fuel into the pumping chamber. A plunger-type priming pump is often used with plunger lift pumps that are mounted on inline injector pumps. It can also be mounted on top of fuel filter housings for distributor-type injector pump systems. The plunger-type priming pump consists of a plunger and a barrel assembly mounted on the side of the plunger pump or on a filter housing. This plunger priming pump uses the valves of the plunger lift pump to direct fuel flow. Plunger pumps mounted on the top of filter housings contain inlet and outlet check valves. Pulling the primer plunger increases chamber volume, which decreases the pressure in the chamber below that of atmospheric. Fuel in the tank is forced along the fuel lines, through the inlet check valve and into the pumping chamber. Pushing the plunger into the barrel decreases the volume in the chamber, which forces fuel out through the outlet check valve. When the priming pump is not in use, the hand knob must be screwed closed. This stops fuel leaking out past the plunger and also stops air leaking into the priming plunger barrel. This section examines the inline injection pump. Some diesel engines use inline injection pumps to meter and raise the pressure of the fuel. The basic principle is for a plunger to act on a column of fuel to lift an injector needle off its seat. Inside the pump is a pumping element and a delivery valve for each cylinder of the engine. The element has a barrel and a plunger that fits inside it. Their accurate fit and highly polished finish ensures only minimal fuel leakage past them without needing positive seals. The barrel usually has two holes or ports, called the inlet port and the spill port. They connect the inside of the barrel with the gallery. The gallery contains filtered fuel from the